At a depth of several hundred kilometers, in the mantle, the temperature reaches to 1,500 degrees Celsius. And at a depth of about 2,900 kilometers, the Earth's core begins, which consists of an inner solid metal core and a liquid outer core. Scientists believe that it is formed by an iron-nickel alloy with various impurities. The temperature at a pressure of 361 million pascals reaches 6,000 degrees Celsius, which is comparable to the temperature of the surface of the Sun. How did the nucleus come into being? Before understanding the source of energy that provides such a high core temperature, let's consider the process of its formation. After the formation of the Sun, the remaining matter that continued to orbit the star began to form huge molten balls, protoplanets, which eventually collided and formed planets. The surface of the newborn planets was bombarded with large bodies, which caused the release of heat, similar to a hammer hitting a nail. When the Earth finally formed, it was a homogeneous sphere of molten rock, heated to more than 1,500 degrees Celsius. At this temperature, most of the heavy elements melted, and iron and nickel began to settle in the center of the Earth, while lighter elements remained on the surface. This is how the core of the Earth was formed. Why is it so hot in the core? Scientists believe that the Earth's core is hot for four main reasons: remaining heat from the formation of the planet, decay of radioactive elements, friction of different layers of the core, the settling of heavy elements, during which their potential energy is converted into heat. The latter factor is considered the main source of heating at the time of the formation of the Earth, but scientists have not reached a consensus regarding its current significance. The primary heat of the Earth's interior gradually dissipates, but friction of the layers, radioactive decay, and sedimentation of heavy elements again release heat, maintaining a high temperature of the core. This raises a logical question. Can all the core heat be dissipated? Can the core cool down? Scientists have also asked themselves this question, but there is no single answer yet, since it is not known exactly what part of the heat in the bowels of the Earth is primary. If it turns out that the main heat is primary, then it will take many billions of years for the core to cool to room temperature. If most of the heat is generated by the processes described, then cooling will take more than 10 billion years. In any case, the Sun will die much earlier, and we will not be able to observe this process to the end.